Hey, party people, people who love to party. It's me, Mr. Beal, here to talk with you today about factoring by grouping. Now, factoring by grouping is kind of like a weird little side hustle that we can do with factoring. I know what you're thinking, Mr. Beal, I don't want a side hustle that has to do with factoring. I want premier name brand factoring. I want the Gucci of factoring. Okay, this is Hey, party people, people who love to party. It's me, Mr. Beal. And today we're going to talk about factoring by grouping. And factoring by grouping is the number one most exclusive type of factoring available. Check it out. So if I'm factoring by greatest common factor, like here, I've got a two terms. There's no squared here, so there's no way this is going to be like our trinomial factoring. This would be like a GCF. My GCF is definitely 5. I pull a 5 out of here and a 5 out of here because 5x is really 5 times x, and 45 is really 5 times 9. And since they have that in common, I can pull that greatest common factor out, ta-da, of the parentheses. This is true of binomial factors as well. So take a look at this. I have x times x plus 5 plus 9 times x plus 5. Well, what do they have in common? X plus 5. So what am I going to pull out? X plus 5 times x plus 9. There's your remaining pieces coming together, just like they did here. The x and the 9 were left over. Those are the things that are still there. That's it. That's all you got to do for grouping. So let's run you through an actual grouping problem. Now it's going to be kind of disguised. As you can see, this is not like the one above, where they were already factored out, and all we had to do was one more step. Right now, we need to convert them to that way that it looked above, where they were already separated, so we know what to pull out. In this case, we're going to take this guy and factor each piece separately. And we're just going to do greatest common factoring on each piece. So as you look at this guy, you're thinking to yourself, well, what goes into both 4x cubed and 2x squared? Well, that would be 2x squared. And what's left over? Well, that would be 2x plus 1, because 2x squared times 2x makes 4x cubed, and 2x squared times 1 makes 2x squared. Now what we need to do, and this is kind of the tricky part, is this guy over here, whatever we pull out, the inside of this has to look like this one was. It's got to be 2x plus 1. So what could I possibly divide by that'll make 26x 2x and 13 1? 13. Then your last step is, well, what do those two things have in common? They've got a 2x plus 1 in common. See why they had to be the same? Because now I can pull that out to the front. 2x plus 1 times 2x squared plus 13. There is the last two collapsing on themselves together. It's factor by grouping, y'all. Let's try it one more time. Because it is the case that we can end up factoring out lots of different numbers. And some of the numbers that you have to factor out are tricky. Sometimes it's negative numbers that are tricky. And other times it's just that factoring out the number 1 is tricky, because you're essentially trying to not change anything. In this case, that's not what's going down. What we've got here is definitely a negative situation. Because if you look at your first two terms, you're going to take out that x squared. And in the front, you're going to have x plus 6. Now in the back, you've got negative 3x minus 18. We're going to pull out that negative 3 so that what's left over is x plus 6. Take a look. Negative 3 times x makes negative 3. Negative 3 times 6 makes negative 18. I've got to pull out the negative 3 so that the x plus 6's are the same. Once they're the same, I can factor out that x plus 6. And I've got x plus 6 is times x squared minus 3 is equal to this whole kit and caboodle. This guy is equal to that. I've just factored it. I've just pulled it apart. All right, quick and easy. Well, at least quick. Try these three if you haven't printed it out. Let me zoom out a little bit so that you can see that last little end bit. There we go. These problems are super long. All righty, guys, pause it, do them, and I'll show you what I got. Let's take a look. Alrighty, guys, you've got x squared plus 4 times x plus 10. Now you may have this written the other way around. Same thing. X plus 10 times x squared plus 4. Multiplication is commutative, so it doesn't matter what order it's in for these two factors. I've got c squared plus 7 times 2x. That's very interesting. That should definitely be 2c plus 7. And finally, 6k minus 1 times 2k plus 5. There you go. Hey, you know how it goes. World crazy. Stay safe.